Today, we're going to walk through an example of test-driven development using Visual Studio 2017, .NET Core 2, and MSTest. Test-driven development uses unit testing. For an understanding of unit testing, I recommend Roy Osherov's website, artofunit-testing.com, and his books and videos as well. Test-driven development is often summarized as red, green, refactor. This is a great mnemonic for remembering the steps, but it's important to understand them in further detail. Begin by understanding one criteria or requirement that can be isolated. Write a test for that requirement so that you will know when it is fulfilled, and if you were to run that test, it would fail because there is no production code to satisfy the requirement. At this point, we are in the red status. Once in the red status, we write production code to satisfy that requirement, but only the minimal amount of code necessary for that test to pass. Once that test passes and all other tests are passing, we are in the green status. From the green status, we move on to refactoring. During the refactoring phase, we refactor both the tests and the production code. When we refactor the production code, we make one small change and rerun the tests to ensure that they all continue to pass. Then we may continue to refactor and make another small change to the production code, run all the tests to ensure that they pass. We continue to refactor with the tests. Once again, we make a small change, rerun all the tests to ensure that they all continue to pass. We can continue to refactor, perhaps extracting a method to be shared amongst multiple tests, and we run all tests again to ensure that they continue to pass, and we remain in that green status. Once refactoring is complete, you repeat the process. Select the next criteria to isolate with a test, have it fail, write the minimal amount of production code for it to pass, refactor, and continue to repeat the cycle. For our journey through test-driven development, we'll be using FizzBuzz, which is a children's game, sometimes an adult drinking game, and often an interview question for developers. The rules are pretty simple. If the number is divisible by 3, say fizz. If the number is divisible by 5, say buzz. If the number is divisible by both 3 and 5, say FizzBuzz. Otherwise, say the number. For example, if on my turn it were 4, I would simply say the number. But if it were 5 on my turn, I would say buzz. The main aspect of test-driven development is having a suite of unit tests for automation as part of a continuous integration process to help establish and ensure quality. Another beneficial aspect is design thinking. We are creating a FizzBuzz application. I've decided that I will implement an evaluator class within the application, which will have an evaluate method. This evaluate method will accept a number and in return tell me what I should say. For example, if I were to ask about the number 3, it would tell me to say the word fizz. But if I were to ask about the number 4, it would tell me, go ahead, just say that 4. From that design, I will have a fizzbuzz.tests namespace for my testing application. Within that, I will duplicate the name of the evaluator for the class that I'm testing. Some choose to also append test to the name of the class. I find that to be redundant. Within that class, I will use the naming convention of method under test, the situation or scenario being tested, and the expected result. So in this case, I know that I'm using the evaluate method in production, so all of my Unit tests will begin with evaluate. Of course, there won't be one for the evaluate method. There will be several. During this video, I will be using several keyboard shortcuts, as I like to keep my hands on the keyboard. Please check to see if yours still match, as you can provide your own custom mapping. With Visual Studio 2017 open, press Ctrl-Shift-N to open the new project dialog. We'll use a .NET Core unit test project, which we will call fizzbuzz.tests, just as we designed, and we will change the solution name to simply fizzbuzz and allow Visual Studio to create that new project and solution for us. We know that we're testing the evaluator class, therefore we'll go into the Solution Explorer with Ctrl-Alt-L. We'll use F2 to rename this unit test 1 default to evaluator, as that is the class we are testing. We press enter. Visual Studio will prompt us to rename the class within the file, which we want to do. Control-Tab into the other window, and you'll see that this is highlighted. So we use our quick actions shortcut of Control-Dot or Alt-Enter to rename it throughout the solution. In the MSTest framework, each test class must be decorated with the test class attribute, and each test method decorated with the test method attribute. Taking aside now to talk about unit test construction. We've already talked about the naming convention that I prefer. Within most methods, you will have an arrange, an act, and assert. Arrange is where you will set up your test. Act is where you will call the production code, that in this case will not exist yet since we're doing test-driven development. And assert is where you test that the results actually match the expected behavior. To explore Visual Studio's Test Runner and Explorer, we're going to pretend that we have a situation where our goal is to produce a 0, but our actual result is a 1. And we will use one of the many assert methods, r=, which will simply see if the result and the goal have the same value. Next, we will execute the test with Control-R, then A. That will run all the tests. Once they have finished, we can use Control-E, then T, that open up the Test Explorer. We can quickly see that we have a failed test because it's grouped that way. We have this icon. For select, we can see the details. That the r= assertion failed because the 1 and 0 are not equal. In this case, it's telling us that the expected was 1, although that was our goal of 0. So why the mismatch? If we look at the IntelliSense for the r= method, the expected value comes first. In this case, that should have been our goal variable. And then second should be the actual, which was our result variable. So this is one reason that I like to name the variables expected, Control-Dot or Alt-Enter to rename, and actual. That way, when I Control-R, then A, run the tests, Control-E, then T, look at the results. Expected 0? Yes, expected 0. It's much more easily translated. Now that we have a failing test, are we ready to write production code? The answer is no, because this code actually has nothing to do with our fizzbuzz program. The first step in TDD is to understand the criteria you want to implement. In this case, we have 4 to choose from. Divisible by 3, divisible by 5, divisible by both 3 and 5, and the otherwise condition. Generally, I like to begin with the one that has the least logic. It's often the default case, the else, or the fall through. In this case, would be that last condition, returning the number. Now that we've thought about our design and gone back to see which scenario we want to implement, we understand that we are going to be testing the evaluate method. Our condition, our scenario, is that the number is neither divisible by 3 nor 5. And in that case, our expectation is that it returns the number. Control dot will rename our method. So therefore, our expected return is any number not divisible by 3 or 5. In this case, we'll use a 2. But what was our actual? Well, think about how we designed this application. Within the FizzBuzz application, we'll be calling the evaluator class evaluate method. So we'll have FizzBuzz calling the evaluator and calling the evaluate method. We will pass it 2 because that's what we're expecting, the same number to be returned. So in this case, I like to just say it's expected. If I ever change this test, it should still work by changing this value. We've now introduced a compilation error. This does not mean that we're in the red status and we can write production code to fulfill the needs of the test. However, we can write enough of stub so that our code can compile. To do so, use Control-Alt-L to open the Solution Explorer. We'll select the solution. Shift F10 will open up our context menu. We'll select D for add. New project is already selected. Once again, we're still using .NET Core, but this time we'll select class library to implement our solution. And as already designed, FizzBuzz is the name of that project and namespace. Visual Studio will create our new project for us. As we designed, we'll use Control-Alt-L to go back to our Solution Explorer. F2 will rename this class 1 to Evaluator. Press Enter. Visual Studio will prompt us to rename it. Control-Tab into the editor, and Control-Dot to use our shortcut to rename it throughout the solution. Now we will go back into our test method. We see that there's still a compilation error. Control-Alt-L to go into our Solution Explorer. Select Dependencies. Shift F10 because we need to add a reference to our FizzBuzz project so that it can see the class. Now we can see that the compilation error has shifted to the evaluate method that does not exist. Let's continue to incrementally stub toward a successful compilation. We use our quick action Control-Dot keyboard shortcut. It will allow us to generate a method called evaluate within the evaluator class. Once Visual Studio has done that for us, we can take a look at the code. It's created a static method that accepts an integer and will throw a not implemented exception, which I find to be very helpful in both test-driven development and in other methods. Running the tests, Control-R, then A. You can look at the results when it's finished, Control-E, then T. We now have a failing test for a production requirement, which means that we are now in a red status. Visual Studio gives us some helpful hints. You see the red icon here that shows us that 0 of 1 test are passing. We can use the Alt-3 combination to bring up that information. We can see which test is failing. If we go back into the tests, we get the same indicator that this test is failing, and Alt-1 will give us information. And that gives us the same kind of detail that we get here in the Test Explorer. Of course, I could make this test pass by using a different method in the assert namespace for throws exception, passing it the type of exception I expect, which I'll need to include the namespace for. If I call a function, in this case we're doing fizzbuzz evaluator evaluate, pass it that 2, and I run all the tests, Control R, then A, we can see that that test passed. Of course, with TDD, this doesn't help us, but it is a good way to exemplify that if needed, we can test for exceptions. So after that detour, let's undo those changes. We'll rerun our tests to ensure that we're back in that red state, and that test has failed, as we expected with the not implemented exception. So we are indeed back at the red state. Now that we have a valid failing test, we can write production code. Once again, we write the minimal amount of code necessary for this test to pass. In this case, we simply return what we accepted, the expected value. We do not write additional logic or anything else more complicated than is necessary, as this helps to reduce the probability that we will introduce an unexpected error into our application. So now, if we run our test with Control R then A, we see that the test has passed. This puts us into the green status. Now we have a passing test for a piece of functionality. We can enter the refactor. We'll refactor both code and tests. I like to start with the code. So in this case, I don't like this parameter name of expected because that will not always be the return type. Instead, I will call it number because I'm going to get a number and this is going to tell me what to say. So we do the rename. We're done refactoring one small piece. So we run the tests again to make sure that we had not introduced any errors in our code and that all the existing functionality still works as expected. And everything passes. So now we can take a look at the tests and see if there's any refactoring. In this case, there's not much happening. There's no duplicated code, and I don't believe a refactor is necessary. Now we repeat. We pick another scenario to test to add more functionality to our code. We could have another neither divisible by 3 nor 5 test with, for example, the number 4, but that really does not help us to advance the functionality of our code base. For the next test method, I'll use my snippet TM, which has our test method attribute for MSTest and placeholders for the 3 parts of the method name. The TM snippet is available as a gist on GitHub. The link will be in the description and at the end of the video. We are still testing the evaluate method. Tab over the condition under test. Next, I want to do divisible by 3. And in this scenario, our expected result is that it returns fizz. Press enter to complete the snippet. Control dot for the quick actions to do the rename. So our expected is fizz. That's what we want to see returned. Our actual is going to be determined by calling the evaluate method with a number that's divisible by 3. In this case, we'll use 3. Save all our changes. We run our tests. And we see that we have one test failing. That means we're once again in the red status. Now we can write the minimal amount of production code necessary for this test to pass. In this case, we just need to test to make sure that the number is equal to 3, because that's what our test is passing. Many will want to actually add the modulus operator here, but in that case, you're adding 2 operations. It's more complexity than is needed for this test case. So we'll finish it out. We'll just return our string, and we'll run all our tests. We'll see that, wait a second, we still have a failing test. Why is that? We can use our test explorer and select the failing test. We see that the assertion that they will be equal expected was fizz, but the actual was buzz. This is the reason we make minimal changes necessary, so that we can find the errors and correct them easily. Correct. We run our tests. And we now see both tests are passing, which means we are back to a green state. Now all of our tests are passing, so we can begin to refactor. Not much here in our code. I will add an extra space here for readability, though it wouldn't actually fail. I've made a change, therefore I'm going to run my tests on the best practice. And all the tests are still passing, so we can look at our tests. Really nothing there that needs refactoring, so we'll move on. So since we know we want to actually add the modulus operator, this test serves its purpose pretty well, so we'll just go ahead and copy and paste it. Of course, it can't keep the same name, so there are various thoughts out there of how to do this, but I will simply just add an _1 to indicate that this is the same test as before. Divisible by 3 returns fizz, but a slight variation because we're going to use some different data. So we're going to run these tests so we have a failing test and go put our modulus operator in there, but they all pass. Thus we see a possible caveat with copy and paste. I never changed the parameter I was passing into the evaluate function, therefore the test did not fail. Simple enough to fix, but an easy mistake to make when copying and pasting. So let's go ahead and change that to a 6. We'll run our tests. Now our test fails, which means we are actually in a red state. We can go into our code now, change our logic. We're going to use our modulus operator. Check to see if it's equal to 0. If so, we should return fizz. So if we run our tests, we see that everything passed, which means we're now in the green status. With all of our tests passing, we can now refactor. If we look at the code, we didn't make much of a change. There's really nothing to refactor. If we think about our tests, however, these two methods are doing exactly the same thing, expecting the same result, just with a different value, the 3 and the 6. So how can we address that? Along with the test method attribute, there's a DataTestMethod attribute. And if we rerun all the tests, just by changing that attribute, the test still passed. There's no functional difference at this point. Once we add a data row attribute, and we tell it, I want to test specifically with this value, we try to run the tests again, we will see that they fail. Looking in the Test Explorer, we can see that it threw an exception for system reflection target parameter count exception. There was a parameter count mismatch. Well, we said I want to use 3 as the value. However, our test method was not accepting any values. Therefore, we ask it to accept a value, and we can rerun our tests. Now we see that our tests are passing. If we look at the different results with our standard test method, the variation _1, we see that it just tells us that the test passed, the name of the test, and the amount of time it took to run the test. If we look at our data test method, we see now that it actually has an extra parameter here telling us that it's passing the 3. In order to add another one, we simply add another data row with a new value. We run our tests again and see that they all still pass, and now we get the second parameter here of 6. So the 2 data rows of 3 and 6 are represented here on a single test with 2 separate results. The question is this actually working as we expect? Well, let's change this to a number not divisible by 3. How about 7? If we rerun our tests, Control R, then A, we see that all the tests are still passing, but they shouldn't be. It says it's passing a 3 and a 7, so why is it not failing? Because we aren't actually using this value parameter anywhere. We need to actually use it in the call to the evaluate function. So if we rerun all our tests now, we now have a failing test. We see that it expected fizz, but the actual was 7. That's why it's very important to make small changes while refactoring and always rerun your tests. So now, if I change that back to a 6, both of these tests should pass. If we rerun it, we see that all of our tests are passing. We're passing our 3 and our 6. We're back in that green status and can continue refactoring. Now that we are using the data test method with the data rows, we are already testing with this variation method, and it can be removed. So as always, we did a refactor, we run all of our tests, make sure things are executing properly. We are still at a green status. At this point, you should have the skills necessary to complete the rest of the exercise. Here are links for reference, also in the description. Next steps, research TDD kata. It's spending 30 minutes a day, deliberately going through the steps of test-driven development in order to build that muscle memory to be able to use it. Along with the FizzBuzz example, string calculator is a common one, and the bowling problem. If you have any feedback, please feel free to leave it in the comments or message me directly. Happy coding.